Hey students, g'day and welcome to our final lesson on matrices for the moment. We're looking at networks and power matrices. So we're going to be able to determine the power of a matrix using technology with matrix arithmetic capabilities when appropriate. And you should be able to use matrices using matrix products and powers of matrices to model and solve problems. Squaring a matrix to determine the number of ways pairs of people communicate with each other in a communication network via a third person. So first of all, when we think about networks, there was a fellow called Euler who wondered if it could cross all 7 bridges without crossing any bridge more than once. So this is a problem-solving question. You might want to pause and have a go at that. So if you start here, for example, on land, if you go like that, no, you can't do that. So what if we start here and go like that? Oh, that doesn't work either. So there's a bit of a challenge for you to look at. Today we're going to look at, first of all, a road matrix. So this is a network diagram. Now this is not a directed network because there's no arrows between the two, there are lots of circles. So this is what we call a road matrix. Okay, so you can see, for example, from town A, B, C and D connecting to town A, B, C and D, there are a number of roads. So if I'm looking at town A, there are no roads from town A to town A, that makes sense. But if I'm starting at town A and going to B, I can see that there is one road. And so we've just indicated that here. I've represented that as a matrix now. I've just put R for road matrix, and you can see my towns labelled on the outside of the matrix. So if we have a look at this R matrix, you can see that it's symmetrical from the leading diagonal. So hopefully I filled that in correctly, and if I look down there, that half should reflect that half, and that's the angle of symmetry. Okay, it shows whether 2 towns are connected by roads. Now you can see that there are 6 roads, so we've just added all those elements together and divided them by 2. So you can see 1, 2, 3, 4, 5, 6, and because that's symmetrical, we've counted this 6 as well and divided that by 2. So you can see that from this matrix that there are 6 roads. You can see it from the diagram as well. Now I want to just use a online matrix generator, so I just typed in online matrix generator and raised that matrix to the power of 2. So I entered in a matrix and just pressed to the power of 2, and it spat out the result. So this is the input and that's the output there to get the next result. So we're looking at power matrices now. So if we have a look at powers of matrices, we've got our rules. So if C equals what, A, B, C and D, then C squared equals one matrix multiplied by the other. But, oh, that's not right. That should be C times C. So I filled that line incorrectly, but essentially what it means is C times C is what we've got here. What else do we need to do? So we've got an incident matrix, so we'll have a look at that. So that looks like this. Now I just used, as I said, the online generator to spit out the R squared matrix. So this is an incidence matrix, so the numbers indicate the direct links, which is the incident between the 2 objects. So here it is. The elements in the first row of R squared tells you that there are multiple ways to travel between the towns, stopping at one other town. Okay, so if I look at the R squared, I'm looking at row 1, 1. It tells me that there are 3 ways. So I can go A, B, A, C, A and A, D, A. So you can see that here. I can go A to C and then back to A to B, and then back to A, and A to C and back to A. A to D, sorry, back to A. And if I have a look at, for example, this one here, so we've got row 3, column 1, what does it tell me? There's only one way to travel from A to C, and you can see that represented in this diagram here. Okay, just to do the same thing to the power of 3, you don't really need to worry too much about this, except for this next example, and we're just looking at two different places then. So if we have a look at powers of matrices, now we've got an R to the power of 3, so I just spat it out of the online matrix generator. And what is this telling me? So the elements of the first row of cubed informs you that there are multiple ways to travel a town, stopping at 2 other towns. So if I look at row 1, column 1, tells me that there are 6 ways to travel from A back to A. So stopping at 2 different places. So for example, that's 1, and then there's 5 others. Okay, now row 2, column, sorry, we're looking at this one, row 3, column 2, tells me that there's 9 different ways to go from B to C. Is that right? No, that looks like I'm starting at C and I'm finishing it at B. Whoops, that's C to B by the looks. Okay, a directed graph or a digraph has arrows and it indicates the direction of travel. So this could be one-way streets, it could be water flow, it could be a computer network, it could be a computer circuit, it could be lines of communication, it could be the boss at number A, and then the second boss at the second level, and the third boss or the pleb down at the bottom of the digraph. So this is lines of communication, for example. So I've drawn this as a matrix. Now, what have I got here? I've got, if I start at A, I can reach C, I can reach B, and I can reach D. So I've got starting at A, B, C, and D. I've got 3 different networks there, so that's fine. Now, if I start at B, I can't go anywhere. So look at that. So I've got zeros there. So that makes sense. If I start at C, I can get to B, but that's about it. And so that's what I've said there. If I start at D, I can get to B, and that's about it. So what do we need to know about this? So the row 1 shows you that you can only move from A. You can move from A to C or B or D. And row 2 shows you that if you start at B, you're not going to reach any direction, any destination. Now if I do the R squared, so I just put that into an online generator and spit out the answer, what do we know? That R12, so row 1, column 2, indicates that there are 2 paths from A to B stopping at one place. And so that's this one and this one. So the stop off is at D and stop off is at C, and that's what's indicated here. And if we want to just calculate the total 1 and 2 stop traffic or step traffic, we're just going to plus those 2 matrices together, and this is what's indicated. So we've got a total of 1, 2, 3, 4, 5. So A can communicate with 5 different places. B cannot do any, so you can see that there's 0 here, so there's 0 here. C is just a 1, and D is just 1. Okay, so now that you've done that, I'd like you to make sure that you can have a go at these learning goals, if you can hit them, and then have a go at the mastery questions.